Welcome to AMAC KSSM channel. This is KSSM at Max Form 5 Exercise Discussion. I'm Madam Wong here.
Formative Exercise 4.1. Question number 1. A set of questions contains 5 true or false questions and 5 multiple choice questions, each with 4 choices. What is the number of ways to answer this set of questions? So altogether we have 10 questions, and the first 5 is true or false question. So each of the questions we have 2 options, 2 options, and 2 options, and 2 options, and 2 options. And then the next 5 questions is formed by multiple choice question, which has 4 choices. So each questions here we have 4 choices, and 4 choices, and 4 choices, and 4 choices, and 4 choices. So altogether it should be 2 times 2 times 2 times 2 times 2 times 4 times 4 times 4 times 4 times 4. So to simplify that, we make 2 to the power of 5 times 4 to the power of 5, which is 32,768. This answer is different from the textbook. Please take note. Question number 2. Find the number of ways to create a 3-digit password for a lock if A. Repetition of digit is allowed. So we draw out the 3 places for the 3 digits, and we know each digit of it formed by 0 to 8. So altogether we have 10 options. So each placing we have 10 options, and 10 options, and 10 options. So 10 times 10 times 10, we get 1000 ways. B. Repetition of digit is not allowed. If it is not allowed, the first placing we have 10 options, and the next placing we have only 9 options. We have to exclude the one used in the first placing. The third placing, I have another 8 options. So basically it was 10p3, which is 720 ways. Number 3. How many numbers are there between 5,000 and 6,000 can be formed from the digits 2, 4, 5, 7, 8 without repetition of digits? And how many of these are even number? So we complete the first part. We are looking for the 4 digits number between 5,000 and 6,000 without repetition of the digits. So 1, 2, 3, 4 digits. And if a number is between 5,000 to 6,000, then the first placing, the 1,000 placing, should be only 5. So which is 1 options to put in 1 place, 1p1. And the rest we can choose from 2, 4, 7, 8. So out of the 4 digits here, we permutate 3 into the 3 placing. So 1p1 times 4p3, we have 24 ways. Now we need to look for how many of these are even number. The same concept. If it's even number and between 5,000 to 6,000, I start with a 5, then 1p1. And the last placing, I can be formed by 2, 4, 2 or 4 or 8. So 3 to put in 1 place. So 3p1. So if I choose 2 here, okay, I've used up my digit number 5 and digit 2 are left 4, 7, 8. So 3 options to permutate into 2 placing. So 1p1 times 3p2 times 3p1. So altogether we have 18 ways. Number 4. A couple and their 8 children are going to watch a movie in a cinema. They book a row of seats. Find the number of ways the family can be seated if the couple A sit side by side. So if the couple sit side by side, then we type them together for 1 place, okay, husband and wife. And then followed by 8 children. 3, 4, 5, 6, 7, 8. And then altogether we have 9 groups. So we have 9P9. And in each placing, the husband and wife can change place. So 2 of them to permutate for 2 seats. So we have 9P9 times 2P2, which is 725 and 1,760 ways. And B, if the couple sits at both ends of the row, so if the couple sits at both ends of the row, then we start from 2 ends, which is husband or wife, right? So the 2 places here can put in either the husband or wife. So basically 2 of them to put into 2 places. Okay, so 2P2. And then the 8 children is in the middle, and there's no condition for the children. So 8 seats permutate for 8 children. So 8P8. Altogether, we have 80,640 ways. C. If the couple sits separately. So if the couple sits separately, we settle down the children first. Alright. So the 8 children, 1, 2, 3, 4, 5, 6, 7, 8, are permuted into 8 places. And then, if I need to separate the husband and wife, I should put in the middle at the end, okay, of the starting, okay, or in the middle, the gap by at least 1 children. Alright. Or here, the gap by 2 children, and so on. The gap by 3 children. Okay. So we only slip in between each children. So we have 9 places here. So out of the 9 places, there takes only 2 placing. So 9 permutate 2. So the product of 8P8 times 9P2 is 2,903,040 ways. Question number 5. Find the number of ways to arrange each word BAKU and BAKA if no repetition is allowed. Are the number of ways the same? Explain. So BAKU, there are 4 different letters. So we permutate all the 4. So 4P4, we have 24 ways. For BAKA, we see 2 identical letters. So from the 4P4, we need to divide the 2 factorial for the 2 A's. So we have only 12 ways. So the number of ways are not the same because BAKU has no identical letters, but BAKA has 2 identical letters A. Question number 6. Determine the number of routes for an object to move from point A to point B if the objects can only move up or to the right. Now, for this question, no matter which route are you using, alright, we try on 2 routes. I can go this way, up, 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 and then turn all the way right. Alright, this is one way. Or I choose another route. I go right, up, right, right, up, right, right, up. So if you notice, from the 2 ways, I go 3 ups and 5 rights. Green, we have 1, 2, 3, 4, 5 to the right. And also 1, 2, 3 up. So they are basically the same, right? Your choice, okay, The roots must be the combination of 5 to the right and 3 upwards. So we need 8 steps. So 8 factorials divided by 3 upwards and 5 to the right. So 3 identical method, okay, which is upward, and 5 identical motion, okay, to the right. So we have 8 factorial divided by 3 factorial and 5 factorial. So altogether we have 56 ways. Question number 7. A group of 7 children are competing for 6 chairs, are arranged in a circle during a musical chair game. The children have to move in anti-clockwise direction around the chair. Determine the number of arrangements for the game. So the children runs anti-clockwise. Alright. And there's 7 children and only 6 chairs. So for the 6 chairs, we permuted 7 children permuted into 6 places. And because in circular in circular way, so we divided 6 for the 6 places. Okay, so we have 840 ways. That's all. Thank you.